Hey everybody, welcome back to Peak State Mathematics. We're going to get ourselves into our next lesson with triangle congruence. We're going to actually switch this up just a little bit and knock out an entire homework quiz here for you. And we'll piecemeal this by timestamp so you can kind of tag along with it inside of this homework quiz. So this might feel a little bit different than some of the other videos we have, but you'll have about a 30-minute video here, maybe 40 minutes, and we're going to piecemeal it and chunk it out, and I'm going to teach all the way through so you can see what we've got. So first thing is going to be this triangle congruence vocabulary. We're going to identify by angles, and then we'll go identify by side lengths. So some of the things that we're going to be paying attention to today is we want to look at, with angles, you could have acute triangles, you could have obtuse triangles, and you could have right triangles if we're just kind of paying attention to just the angle measurements to get us there, okay? So for the acute, this means that all angles are less than 90 degrees. So they're all these cute little tiny angles, right? Just these little tiny small angles. And then an obtuse would have one obtuse angle. So one angle that is greater than 90 degrees. That's going to be our obtuse angle, right? The big angles. And then for our right triangles, obviously would have one right angle in it. So one that is actually equal to 90 degrees, okay? So as we take a quick look at this one, we're going to use this diagram for the first three questions. The first thing you want to be able to identify is, how do I even read this like question, right? This is the symbol there is triangle. That's that first symbol is triangle ABD. And so what I like to do is I literally start at A, go to B, then to D, and I'll complete my triangle like this. And so let's pay attention to the angles to help us identify everything. Obviously, angle 25 is already given there, that measurement of 25 degrees. This is a piece that is letting us know that triangle up above is an equilateral, which actually is going to be the second question here, but this will help us for the rest of it. If all three of those angles are the exact same, and we know triangles add up to 180, then we know each of these angles is 60 degrees. That's 60 degrees, that's 60 degrees, this is 60 degrees. And then if we've got two angles that form a straight line, these are our linear pairs. And so I can say that 180 minus the 60 degrees we have right there is going to give us the remaining 120. So this is 120 degrees inside there. And then with our triangle sum theorem, we know that the 120 plus the 25 plus something else is going to equal our 180 degrees. And so if we look at this 145 degrees we already have, we can take it away from our 180 and we'll be left with a total of 35 degrees for this remaining angle, okay? So now obviously looking at this triangle with all the numbers, this is much, much easier. And you're like, oh, this has definitely got an angle that is greater than 90 degrees. And so this must be an obtuse triangle. And so for our first one here, let's go ahead and do the drop menu and select our obtuse triangle, okay? All right. The next thing we're going to see here is we're looking at BCD. So again, using this diagram, BCD, we've already talked about this, but just again, quick recap. These symbols mean they are congruent, and if all three are congruent, then three congruent angles, then we know this is an equilateral. Okay. We do know that they're all 60 degrees in measurement, but more importantly for the name here, we know this is going to be an equilateral triangle. So equilateral, okay. And then let's look at the third one here. What's the most accurate for ACD? So coming back, we've got A to C to D. And so as we look at this, again, the information we found earlier, this is 60 degrees, this was 35 degrees. And then this angle measurement Okay, if we look at those two pieces together, is a 60 and a 25. So 60 plus 25 is going to give us an 85-degree angle there. And so we see all three angles are less than 90 degrees. So this would be our acute triangle. Okay. All right. So hopefully that is helpful for you to kind of get you going. What I would encourage you to do right now is hit pause. Try these next three on your own, and then watch back through this. And I'm going to go through this much, much faster for these extra steps. Okay. So hit pause. We'll see you in just a second. All right, number four. Number four, what is the most accurate for ABE? ABE, ABE. Obviously, it gives us that little square box, which means right angle. And if we have a right angle, then we must be a right triangle. What's the most accurate for ABC? So ABC, now we're looking at that piece, that element. If this is 115, then we've got 180 minus the 115. Remaining 65 degrees must be that part on the inside. I don't necessarily know this one at this exact moment. I can go find it, right, because of the triangle sum theorem. But I do know it has to be less than 90 degrees because it's cutting through that right angle. So for the sake of this answer, I'm going to say, okay, 75 is less than 90, 65 is less than 90. That cut through the 90-degree angle has to be less than 90. So this is going to be another acute triangle. Okay, or if you wanted to, go find that angle measurement just to make yourself feel better. We've got the 75 plus 65 gives us 130 plus 10, so 140. So then our remaining angle must be 40 degrees, and sure enough, that confirms it for us. Okay, number 6, what's the most accurate for DCE? DCE. Okay, kind of a similar approach here. Let's go take a look. You know that this angle measurement is still 65 degrees. That's a vertical angle there that could have helped us. Or again, we've got the linear pair. And then 65 and 37 gives us 102. And so our 180 minus the 102 gives us a remaining of 78. So this up here must be 78 degrees. And once again, all of these are less than 90 degrees. So we are left with an acute triangle one more time. Okay, good job with that. Let's jump into the second component of this homework quiz. So we're looking at identifying them now by side lengths. So the side lengths that we're going to look at are going to be no congruent sides will be called a scalene triangle. If we have two congruent sides, then we're going to call this isosceles. And if we have three congruent sides, so all three sides are congruent, then we'll call this equilateral. Okay. Now, there are going to be a couple other things in here. Like we could identify if it's a right triangle with Pythagorean's theorem. So please note that that will be one of those options in there. And so using a squared plus b squared equals c squared, we can determine if it's a right triangle. If this is true, then this would be a right triangle. So note that that could be an element in here as well, either now or later when we do some of the review stuff and a couple other practice problems. So let's look at these then. We've got what's the most accurate for CAE, C to A to E. I've got 4, 4, and 7. So with two congruent sides, we're going to go with isosceles, okay? So two congruent sides equals isosceles. Next one is ADE, A to D to E. And so we're looking at 4, 3, 2. all three of these are going to be uniquely different. And so with three different sides, this will be our scalene. Okay, so scalene there for number 8. And then again, at this point, hopefully you're feeling comfortable with it. So go ahead and pause me again. Go ahead and try these on your own and see if it goes well for you. All right, welcome back. We're jumping into number 9, BED. BED. Our side lengths are going to be 2, 2, and 2. And so with 3 congruent sides, we know this is going to be an equilateral. Equilateral. Okay, so equilateral triangle. All 3 parts are equal or the same in length. So equilateral. What's the most accurate for ABC? So now we're looking on the bigger element here. This takes a little extra step, right? You've got 7, and then you've got 3 and 2, which is 5, and then you've got 4 and 2, which is 6. And so you've got 3 different side lengths here as we look at it in the parts. And so this must be scalene. Okay, perfect. Nice work with identifying. That gets us through kind of the vocabulary part of our lesson. So now we're going to look at the exterior and interior sum theorems. So the statement here is that all 3 interior angles of a triangle will add or sum to 180 degrees. Well, you might be like, I don't know how that would be possibly true. Let's go take a quick look at an example. So if we saw some triangle, okay, and then we were to throw some parallel lines on this bad boy. So here's a line. Here's a line. Okay, let's pretend I did a really good job of making those parallel. And then I've got this transversal here. And I've got this transversal here. Okay, so let's just pretend I did a really good job of drawing all those. Okay, you've got this angle measurement here. This angle measurement here. And let's go with this color. I already did orange. Let's do, we did red already. Yeah, I don't have much left. We're going brown. Okay, let's go brown. So I want those 3 angles to add up to 180. Well, one of the things that I know adds up to 180 is a straight line. You know, like if I go all the way across that straight line, it'll be 180 degrees. So if I have successfully, strategically drawn these so that these are parallel lines, we know that alternating interior angles are going to be congruent. So this is going to be congruent here and here. And this is going to be congruent here and here. And what we've just successfully done now is we've drawn these 3 angles from the triangle up into a straight line, and we now can prove that it adds up to 180. If you're more of a visual learner and you like kind of more the hands-on, you want to play around with it, here's another example that we could do. Okay, so here's another random triangle. Let's say that it's got that angle measurement, this angle measurement, and this angle measurement. Okay, and I want this to create a straight line again. You can basically take your drawing 3 different times, and you're going to try to create it so they line up into a straight line. So if I take 2 of these triangles and make them form that straight line, I now have the blue and green angles. I need to see, can I make this red angle basically fit there? So if I take my triangle and I spin it so that it matches up, it should be able to drop right in here as a perfect fit. Something like that. That's pretty cool. Okay, so this is more of a visual hands-on. Like you can do this with paper too, right? Cut up your triangles, splice them all together, and go ahead and like line them up on the table, and you can actually see all three of your angles will line up. Okay, so there's your proof for this. More mathematically, this will state that the sum of measure of angle 1, measure of angle 2, and the measure of angle 3, when I add them all up together, it's going to equal 180 degrees. So why is that important? Let's go ahead and try number 11. So we're going to give you that this is 75 degrees. Now, measure of angle 2 is 32 degrees. And I want you to go find the measure of angle 3. So plugging into our formula, then we see that this is 75 degrees plus 32 degrees plus something. Let's just keep calling it measure of angle 3 equals 180. And so 107 plus the measure of angle 3 equals 180. Subtract the 107 from both sides. And we'll see that the measurement of angle 3 is in fact equal to 73 degrees by our triangle sum theorem. Okay, so I now know this is 73 degrees. Go ahead and type that in. And then again, required format, just give it as a number here, so just 73. And then if this is 73, I can go find angle 4 because these are supplementary, right? It's going to be this linear pair. So if I do my 180 minus 73, I'll get 107 as an angle 4. Anybody notice something there when I wrote that number down? 107 is equal to, the sum of the other two angles. This is actually the proof, basically, for the exterior angle theorem. The exterior angle theorem states that this angle here, the exterior, the one, if you extend one of the sides of the triangle, the exterior angle is equal to the sum of the two interior angles that are not attached to that exterior. You might call it the two remote interior angles. Okay, so there is the answer for the next one there as well. We wanted to go find angle 4. So this is 104 degrees down there. 104. Oh, no, not 104. Why did I write 104? 107. 107. Let's do that. 107. Silly. I think I saw the angle 4 and lost track of it. It says 107 and 73. Okay, so 107, 107, 107. There we go. All right, so that's kind of a nice little kickstart for you. Again, go ahead, pause me here. Try this one on your own. There's a lot more angles going on. See if you can piece all the elements together, and we'll go from there. Okay, so good luck. I'll see you in just a second. All right, first element that you need to do is plug in all of your given stuff, right? We've got measure of angle 1 is 36, so I know this is 36 degrees. Measure of angle 2 is 53 degrees, so this is 53 degrees. And measure of angle 6 is 64 degrees. And then we're basically going to have to go find all the other angles here. So I prefer just drawing the picture, find all of the angles, and then we'll go back through the answer key and knock them all out. So let's take a look at this. The first part I would start with is I already have 2 of the 3 angles here. So I can quickly go find angle 3. 36 plus 53 plus angle 3 is going to equal 180. So 89 plus measure angle 3 is going to equal 180. Measure angle 3 when we subtract 89 from both sides is 91. And so this is 91 degrees. Okay. Two things that we'll be able to quickly fill in now. First is these are vertical angles. So you probably already identified that angle 7 is also 91 degrees. That's good. You'll also remember from our exterior angle theorem we just talked about that the sum of these two remote interior angles is equal to the exterior. And so we know that 89 is our angle 4. So angle 4 is 89 degrees. And we saw that this was also equal to angle 7. Okay, so we've got a couple of the elements taken care of. Well, now we know that a couple different ways here. We know that 64 and 89 are two of the interior angles over here for this triangle, if we want to go find it. Or using your exterior angle theorem, you could take a look and say that, oh, hey, this 91 is equal to the sum of these, so this must be 27 degrees. All right, so I know that 64 plus the measure of angle 5 is equal to the measure of angle 7, which is 91 degrees. Okay, this is one way you could do it. And so measure of angle 5 would end up being only 27 degrees when we do that. You could double check this, obviously, with the triangle sum theorem. You got 64 plus 89 plus angle 5 equals the 180. And so this is what, 153? Yep. Plus angle 5 equals 180. Take it away from both sides and we'll see once again that angle 5 is 27 degrees. All right, well, if that's 27 degrees, you've got a linear pair right there. So 180 minus 27 is 153. Okay, or take a look at, you got your exterior angle theorem going on again. Angle 6 and 4, add them together. That was our 153. So this is 153. Parallel lines. There's a lot going on here, isn't there? Parallel lines right here. So you know that corresponding angles are congruent. We know that angle 10 is then 27 degrees. And corresponding angles over here, there's 4 and 9. This must be 89 degrees. Okay? So all sorts of stuff kind of piling together here. And actually what's fun is you actually might even notice right here that, let me clear some of this out. You might have noticed that this little triangle right here had the same angle measurements as this bigger triangle here, and that was because with this parallel line, we know that corresponding angles are congruent, and so we'd be able to see that those are actually similar triangles. We'll talk about that in another unit down the road. Okay, so there's all of your answers for you. I'll bring that one back on the board here real quick. You've got 36 is given, 53 is given, which allowed us to find 91 for measurement of angle 3. Then we used vertical angles, so that 7 was also 91. And then we used our exterior angle theorem or supplementary to go find measure of angle 4, which was 89 degrees. 64 was given to us. That was angle 6. We can then use the third angle theorem or the exterior angle theorem to find that 5 was 27 by parallel lines. We see that 10 is 37 by parallel lines. 4 and 9 are congruent, so 9 was 89. And lastly, either by exterior angle or supplementary, we see that 8 is 153. All right, I'm going to take a quick pause right there and we're going to reset. So thanks for joining us. I'll see you on the next video.